In this video, we show how to simplify the following division problems where we're dividing by a pure imaginary number or just a real number. This is part 5 of complex numbers. So far we've defined I as the square root of -1 so that I squared equals -1, and we've simplified, added, subtract, and multiplied complex numbers. Now we're going to divide complex numbers. Let's take an example. 3 divided by I. Okay, so why isn't this simplified? When I have a complex number in the denominator, which means I have an I, you might have 3 plus I, you might have square root of 2I, but as long as there's a complex number down there that has the I in it, it's not simplified because that means you have a square root in the denominator. So how do you normally get rid of a square root? Let's just remind ourselves. What if it was 3 over the square root of 2? Do you remember the trick? We could multiply the top and bottom by square root of 2, and that gave us a 2 in the denominator. We didn't have a square root, no irrational number. So we're going to do the same type of thing here. The trick is to multiply the top and bottom by I. Now what happens when you multiply the top and bottom by I, the numerator and denominator by I? We have 3I in the numerator, but in the denominator we have I squared, which is not a square root, because I squared is just -1. So I get 3I over -1, and then when you divide a number by -1, it just changes the sign in the numerator. So that is the answer. So when you're dividing with complex numbers, and what I mean is if you have a square root of a negative number somewhere in the denominator, if it's a single term, you could just multiply the numerator and denominator by I. So let's look at another example. Let's say we had -5 divided by 2I. Okay? Again, I have a single term in the denominator, but I have an I. That's a square root, so I do exactly the same thing. I need to get rid of that I, just like if it was a 2 times the square root of 3, so I'm going to multiply the numerator and denominator by I. Now what happens in the numerator? I have -5I, and in the denominator I'm going to have 2I squared. Okay, so I have -5I. Now, what happens in the denominator? I have 2 times I squared. That's 2 times -1. I'm sure some of you don't need to write every single step out here. And then the last thing is, you've got a negative divided by a negative, so that's just 5I over 2. So, finally, I'm going to write that as 5 halves I. That looks like BI. Now, it's okay if you want to write it as 5I over 2 as well. This just is sort of in the A plus BI form. The real part's 0, so you don't see the 0. Okay, let's do another one. Well, how would we do this problem? Notice in the denominator I do not have an imaginary number, but it's still not quite an A plus BI form. So for this problem, since there's just one term in the denominator, all we need to do is split up the numerator. 9 over 3 minus 6I over 3, which is 3 minus 2I. And there we have it in A plus BI form. What if it was divided by 3I? Okay, it's similar. We begin the same way. 9 over 3I, I'm going to leave a little space there, minus 6I over 3I. Okay, now look at the first term here, 9 over 3I. There's a couple things you might notice. There's an I in the denominator, but also I can cancel that 9 over 3. So let's cancel that 9 over 3, and I'm going to have a 3 in the numerator. But I have to deal with this I in the denominator, and we're going to do that same trick. If I multiply the numerator and denominator by I, I'll have an I squared in the denominator. So this first term will end up being 3i over I squared. Now, could we go a little bit faster here and instead of writing I squared, write negative 1? Hopefully you're okay with that since I squared will be negative 1. Now let's look at the next term. Well, the i's completely cancel here. And so I have just minus 6 over 3. So that'll be a minus 2. Okay, almost there. Okay, 3i over negative 1, you want to write as negative 3i. And what's the last thing? We want to put it in the form a plus bi. That's the simplified way of writing complex numbers. So negative 2 is the real part, so we just write that first. Negative 2 minus 3i. Okay, before going on, pause the video and try these two problems. You want to put them in the form a plus bi. Okay, let's do the first one. Well, here I just have a single term in the denominator that is an imaginary number. So the trick here is to multiply the numerator and denominator by I so that I have that I squared in the denominator. So this gives me 3i over what? What's it going to be in the denominator? I have 4i times I. That's 4i squared, right? And I squared is negative 1. Okay, so I'm skipping writing that step. And this minus 1 means the whole problem is negative. So we can just put the minus out in front. Negative 3/4 I. I wonder if any of you noticed what happens when you have just an I term in the denominator, like in the form bi. Basically, it changes the sign and the i's in the numerator. Anybody notice that? You might look back and see if you see that pattern. In other words, if you have b over ai, if you multiply the top and bottom by I, you end up with bi over ai squared, right? And ai squared is negative a. So you end up with negative b over ai. So look at what I started with right here, and look at what I end up with right here. If you have an I in the denominator, after you do these steps, you end up with a different sign in front of the fraction, if it's a fraction, and the I is now in the numerator. Okay, let's go to the other problem. Okay, we want to begin by, since I have one term in the denominator, we want to write each of the terms in the numerator over 6i. So I have negative 8 over 6i plus 12i over 6i. Okay, so in this first term, let's move this over just a little bit. What can I multiply the numerator and denominator to get rid of this I in the denominator? An I, unless you do the shortcut I just showed you. And so also the 6 goes into the 8, so I could also do that. 2 goes into both of those numbers. So what happens here? I've got a negative 4i in the numerator, and in the denominator I have a 3i squared. Okay, 3 times I squared. 3 times negative 1 will be negative 3. Okay. Next term, the i's cancel, and the 12 over 6 cancels, so I end up with just a 2. All right, now we want to write that as a plus bi, so we put the 2 first. And what's this? Well, negative over negative is positive, so that's going to be plus, and let's write that as 4/3 I. So in this video, we just worked with dividing complex numbers where we only had one term in the denominator. So it was usually 4i, 2i, etc. In other words, it was a pure imaginary number in the denominator, and the trick is you can multiply the numerator and denominator by I. In the next video, we'll go over how to divide complex numbers when the denominator is in the form a plus bi. So we'll be doing problems such as 3 over 1 plus 2i, or 5i over 3 minus 4i, or 1 plus 3i over 5 minus I. Problems like this, it will not work just to multiply the numerator and denominator by I. So we'll have to use another technique. That'll be in the next video.